I'm Tammy Kolda, an applied mathematician, and this is Unlocking LaTeX Graphics. On this channel, I present tutorials on using TXE and pgfplots. These videos are based on my book, Unlocking LaTeX Graphics, as well as some bonus materials like today. In past episodes, I've shown how to read data from external files and plot it using pgfplots. Today, I'm going to show you how to work with tables directly using the pgfplots table package. I'll show you how to read data from external files, display it as a formatted table, use it or reuse it for plots, plot values computed from the table contents, add new columns to an existing table, and create tables from scratch. Although you will see that this episode has many uses, I've created it as part 2 of a series on plotting slope fields. I will link that series in the show notes. So let's get started. Let's set up our document. I'm using the geometry package with 1-inch margins. I'm using parskip to avoid paragraph indentation and the hyperref package to link the author name to the YouTube channel. The key packages here are pgfplots and pgfplotsTable. The pgfplotsTable package is the focus of this video. It handles reading, displaying, and manipulating tabular information. In the pgfplotset block, I set the compatibility to version 1.18. I use scale-only axis, which I've covered in previous videos, and I set the width and height to 5 by 8 centimeters. Our data file today I'm calling samples.txt. It contains measurements for 10 hypothetical patients, an ID code, a gender indicator, just male or female, height in inches, and weight in pounds. I made the column names very short to make it easier to display this in the code. To prepare for our first plot, I'm first going to define a plot style that we can reuse over and over again. I'm using pgfplotset and defining a style that I'm calling mfscatter because I'm going to differentiate the male and female classes in the scatter plots. I've covered scatter plots in a prior episode that I'll link in the comments. The option scatter tells pgfplots it's a scatter plot. The option only marks tells it not to connect the marks with a line. The option scatter source equals explicit symbolic tells pgfplots that I'm going to specify a meta column that will be used to tell how to color things. Then the scatter/classes defines 2 classes M and F with different colors and marker styles. Note that there is no comma following the second definition. If there were a comma, then that would cause an error. The legend entries are male and female, and that has to be in the same order as I've defined them in scatter classes. I talk about the pitfalls of the cycle list in a past episode, which I'll link in the show notes. This sends a bunch of default plot styles, and that turns out to screw up what we're doing with scatter classes. So I'm just setting it to empty because we don't need to use it anyways. Now let's go ahead and plot this data. I'm setting up a pgfplots picture. I'm using the plot type we just defined named mfscatter. I'm setting the X and Y labels, and I'm putting the legend in the northwest corner. The addplot table command reads the data directly from the samples.txt file that I showed you before. I specify that the X values will be H using the heights column, and the Y values will be W to use the weights column. The meta value, which will be used for our color coding, as G. Once I compile, you can see the scatter plot with blue circles for male patients and orange diamonds for females. So far, this is material that we've covered in past episodes, so let's get to some new stuff. The new thing we'll do is read in the data outside of the addplot command. We can store it and reuse it multiple times. The command pgfplotstableread reads the file samples.txt, and it stores it in a macro I'm calling \samples. You have to include the pgfplotsTable package up at the top for this to work. The pgfplotstabletypeset command displays the table. I pass the option string type so that all columns are treated as strings rather than numbers. Otherwise, pgfplotsTable would try to parse the ID and gender columns as numbers and fail. Again, you need the pgfplotsTable package to use this pgfplotstabletypeset command. I can make this table more nicely formatted. Let me scroll back up to above this and add some defaults. There is a pgfplotstableset command similar to pgfplotsset. I'm specifying here to draw lines above and below the header line and below the last row. There is actually a lot you can do with displaying these tables, and that might be a topic for another episode. If you are interested in learning more about that, please let me know in the comments. When we recompile, we see that the table looks nicer. Finally, let me show you that you can use the /samples macro to plot the data instead of reading from the file again. If I go down here where we have samples.txt, I can just change that to samples, and nothing changes in the table because it's just exactly the same data. I'm going to do another example. Now I'm going to use the same data, but I want to plot something called the body mass index, or BMI, on the y-axis with patient IDs on the x-axis. The challenge is that the BMI isn't in our data file. We need to compute it. And the x-axis labels are strings, not numbers. Let me show you some new tools that we can use. First, I'm going to go ahead and paste another plot. I'm using a new way to specify the x and y values in the addplot command. Instead of x and y, I use x expression, expr, and y expression to specify expressions that are evaluated for each row of the table. I use x expression equals \coord index to use the row index as the x coordinate. In other words, the x values are the row numbers starting from 0. For the y value, I use y_expr to calculate BMI on the fly. The usual formula is mass in kilograms divided by the square of height in centimeters. The 703 factor converts my data, which is in inches, in pounds. I read in the weight using this row and W, and then I'm taking the square of the height by reading this row h twice and multiplying it together. I'm reading from samples using the table we already loaded. When I compile that, we get the table you see here. The plot looks good, but the x-axis shows numbers instead of patient IDs. Let's go ahead and fix that. First, I'm going to say x_tick equals data to place a tick mark at every single data point rather than every other data point. None of them are skipped. We want them all to be displayed. Now I have a very cool option for you. This is x_tick labels from table. You put the table name. It could be a macro, it could be the data file, and then the name of the column that you want to pull your labels from. When I recompile that, it's now using these labels that we have here as the markers of our tick marks. Now, these are running into each other, so we need to fix that. The last thing we'll do is change the tick label style. So here I'm setting the font to small, I'm rotating it 45 degrees, and then I'm anchoring it at its east anchor in the Tixie box that we make. Now we have a nice figure using several new tricks. Now I'm currently computing the BMI right inside the addplot command, but I could put the BMI column into the table itself using pgfplotstablecreatecol. Let me go back up here after I read the table, but before I display it, I'm going to add this pgfplotscreatecol. The command pgfplotstablecreatecol takes an options block with the createcol/expression that says how to create it. Then I have the name of the new column, BMI, and the name of the table that I'm going to add it to. This expression is the same as what we used before, and it's accessing the rows of the table to compute this new value. Then I call pgfplotstabletypeset to display the updated table. I'll recompile that. And now we see that we have our BMI values. Notice that the column is showing oddly because I'm treating all the columns as string style. I've been cheating a little bit. Let me fix that. So to fix the display, I'm going to actually specify that only the first two columns are string type. So I'm going to replace this line here, and now I'm not saying that every column is string type, just ID and G. And when I recompile that, Now all the number columns are treated as numbers and formatted appropriately. Now that the BMI column is part of the table, we can use it directly in our plot. So I'm going to go down here, and instead of this complicated expression, I can replace it with just y equals BMI, and the table is the same as we had before. So far we've read data from an external file and manipulated it, but pgfplots can also create a table from scratch. So let me scroll down here and we'll get a whole new example. pgfplotstablenew creates a new table. So how does this work? I have a set of options with a bunch of create on use columns named X, Y1, and Y2. These are computed on the fly using expressions, and I'll come back to that. I instantiate those columns by saying that the columns are going to be X, Y1, and Y2. So I could have this defined, and if I didn't say it was a column, it would never be called. The last two arguments are not optional. It's the number of rows in the table and then the name of the table. I'm going to call this /scratch. The formulas are similar to the X expression and Y expression in the addplot table command. However, there's no coord index here. For some reason, they made it something different. And so here it is pgfplotstablerow. That gives you values between 0 and the number of rows minus 1. And then to compute the X values, I'm going to take that value, divide it by 2, and subtract 5. The result is X values from -5 to 5 in increments of 0.5. For Y1 and Y2, I compute the cosine and sine of those X values. We can see the result when I display it using pgfplotstabletypeset macro. And so here's all our values. Now let's plot what we've just computed. So I'm going to go down here and paste a Tixie picture. I have two addplot commands, each reading from this table we just created called scratch. The first plots Y1 in magenta with asterisk markers, and the second plots Y2 in cyan with circle markers. So when I compile that, we get to see it. Remember that the X values are always defaulting to the first column, and since our X values are our first column here, I don't have to manually specify it. So now we've created a table from scratch and plotted it. I hope you enjoyed today's episode on working with tables in pgfplots. We've covered how to read data from a file with pgfplotstableread, how to display it as a formatted table with pgfplotstabletypeset, how to plot data directly from a table, macro, how to compute values on the fly using expressions in addplot, how to add a computed column with pgfplotstablecreatecol, and how to create a table entirely in LaTeX with pgfplotstablenew. Because pgfplots tables can be very persnickety, I generally recommend creating tables entirely outside of LaTeX. If you run into any problems using these tools, it's usually much faster to create a new data file with a quick Python script than to try to debug the pgfplots table code. That can be a place that's very difficult to get out of. I include a link to the overleaf document I created today in the show notes. If you found this helpful or interesting, please click like or subscribe. If you have Tixie or pgfplots questions, please post them in the comments. If you want to learn more, please check out the other videos. I also have a book, Unlocking LaTeX Graphics, available for purchase at major book retailers. Thanks for watching.